Problem number one, they give you a picture, it looks like this. They want you to list the angles from smallest to largest. So smallest to largest, well, we locate the shortest side, which is right there. The angle across from it's got to be the smallest angle. So we're going to say angle N is the smallest. Use the alligator mount. Then the next shortest side is 18. That's across from the next smallest angle, which is angle L. And then the longest side has to be across from the biggest angle. Use the other alligator mouth, angle M. So that's the answer to number one. That's the answer to number one. Number two, we look at number two. We notice that these two sides are actually the same. So neither one of them is going to be smaller than the other. So we're going to say angle D is equal to angle E. I'm sorry, not angle E. I wrote that wrong anyway. This one's across from angle D. This one's across from angle F, not angle E. So angle D and angle F are congruent to each other, or equal to each other. And then the 8x, which is going to be the longest, is across from the biggest angle. So that tells us that angle E's got to be bigger than both of those. So that's your answer, number two. Number three, first thing we got to do on number three is find that third angle. When we find that third angle, add up the two angles. 27 plus 81, that's 108. Subtract that from 180. 180 minus 108 gives you 72. Tells you that third angle right there has got to be 72. We want to, again, this time we want to list the sides in order, not the angles. So if we want to list the sides in order, and this time instead of using the alligator mouse, I'm just going to use a comma. We want them to be from shortest to longest. Well, this 21-degree angle's got to be across from the shortest side, so segment AB's got to be the shortest, comma. Next shortest is across from the next smallest angle, which is 72, so AC has got to be the next shortest side of the triangle. And then the 87 is always across from the longest side in this case, so that's got to be segment CB or segment BC. Number four, on number four, we don't know the angles. We know they got X's in there, so what we're going to have to do on number four is set up an equation. We know that the three angles of a triangle must add up to 180. So X plus 2X plus X minus 4 has to equal 180, and this is for problem 4. I know I'm up here on all the other problems, but so then X and 2X and X, that gives us 4X minus 4 equals 180. Add 4 to both sides, you end up with 4x equals 184. Divide by 4, and if you use your calculator, I believe x equals 46. Once you know x is 46, then you go to this angle. That means this angle right here is 46 degrees. 2 times 46 is 92 degrees, so that angle is 92 degrees. 46 minus 4 is 42 degrees. So this angle right over here is 42 degrees. Now we can list the sides. We want the shortest side. Shortest side is going to be across from the smallest angle. That's that angle, so that's PQ. I'm going to use the alligator mouth again. PQ has to be less than the next shortest side, which is across from the 46-degree angle, segment PR. And then the biggest side has to be across from the biggest angle, which is 92 degrees, so segment QR. And that's your answer on number 4. Listing the sides of the triangle, shortest to longest. Again, we don't know what any of those measurements are, but we know which one's the shortest, which one's the longest. Next one on number 5, to check, see if this can be a triangle or not. All you're going to do is you pick two sides, 15 plus 37, that should be greater than 53. You check that, 15 plus 37 actually ends up being 52. 52 is not bigger than 53. So this one, the first one we checked, told us that no, it can't be a triangle. Any two sides must add up to be more than the third side. This one, check this, 9 plus 16 should be greater than 8. Well, 9 plus 16 is bigger than 8, so that checks. Doesn't mean we stop, we check the rest of it. We do 9 plus 8, and that should be greater than 16. 9 plus 8 is 17. 17 is greater than 16, so that checks. And then we do the last pair of sides, which would be 16 plus 8, and that should be greater than 9. 16 plus 8 is 24, and that is bigger than 9, so this one is, yes, those could be the sides, and this is our proof. That's our explanation why it works. All right, number 7, sort of a tough one. Just not really tough, just takes a little longer. We know that any two sides of a triangle must add up to be more than the third side. So if we pick any of these two sides and set it up to be greater than the third side, we're going to have to do that all 3 times. And then that's going to tell us something about what x could be in this case. It's not going to give us an exact answer for x again, but it's going to tell us that x has to be something. Sometimes it'll give you just a real simple answer, other times it might give you a little better answer. This one doesn't give us a real great answer, but it's as close as we can get, as much as we can get on this one. So the first thing I'm going to do, I'm going to set this up, 2x plus 1 plus x plus 16. That's these two sides added together, and that should be greater than the third side, 2x plus 31. Hopefully you remember solving inequalities in algebra. Sort of the same thing as solving equations. You do the same steps. The only thing that's different is when you divide or multiply both sides by a negative is the inequality symbol flips around. So if it's a greater than, it becomes a less than, and so on. Here I'm going to do this sort of quick. Combine the x's, we get 3x. Combine the 1 and the 16, we get 17. That should be greater than 2x plus 31. We move the 2x over to this side. That means we got to subtract off 2x. We end up with x plus 17 is greater than 31. Subtract the 17 on both sides, and we end up with x is greater than 14. So we right now know that x has to be bigger than 14. Now that doesn't mean that that's all x can be. That's just one of the things. So we got that. Then we pick 2 other sides. I'm going to pick 2x plus 1 plus 2x plus 31. And that should be greater than the third side, which is x plus 16. We collect like terms again. That's 4x plus 32 is greater than x plus 16. I'm going to move the x over to here. That means 3x. You subtract x on both sides. I'm doing a lot of this in my head. I'm going to move the 32 over to there. That means we subtract 32 from both sides. Well, 16 minus 32 is a negative 16. We divide both sides by 3. Well, when we divide both sides by 3 here, we end up with x is greater than a negative 5 1/3. Well, we know x has to be bigger than negative 5 1/3 because x, the lengths of the sides, I guess the x could be negative, but we now know that x has to be greater than that. Well, we look back over here and we already know x has to be bigger than 14. So this one really doesn't matter because we already know x has to be 15, 16, 17, 18. So to be greater than negative 5 1/3, we already knew that from this one. So this one here doesn't really help us any. We do the other, match up the other sides. We do x plus 16 plus 2x plus 31. And that should be greater than the third side, which is 2x plus 1. Collect like terms, x and 2x give you 3x, 16 and 31 give you a 47, should be greater than 2x plus 1. Subtract 2x on both sides, you end up with x plus 47 is greater than 1. Subtract 47 on both sides, you end up with x is greater than negative 46. Same idea on this one. We already know x has to be bigger than 14, so we know that it's got to be bigger than negative 46. So this one doesn't really help us either. The most that we can say about x in this problem is that we know x has to be larger than 14. That's the best the best description we can give for x. We can't say any more than that about it. Sometimes you'll be able to say x has to be between two numbers, depending on the way the math works out. Problem number 8, they give us this, and they want us to list the angles in order from smallest to largest. Well, the first thing we got to do is figure out what x is so that we can figure out all the angles. And we had a theorem earlier this year that said these two non-adjacent interior angles must add up to equal that exterior angle. So that's the equation I'm going to set up. 6x plus 4 plus 4x minus 2, and those should equal 9x plus 16. Collect like terms, 6x and 4x give you 10x, 4 and negative 2 give you a positive 2, and those should equal 9x plus 16. Subtract 9x on both sides. We end up with x plus 2 equals, these cancel out, equals 16. Subtract 2 on both sides. We end up with x equals 14. Once we know x is 14, we can plug that back in here and figure out what each angle is. 4 times 14 is 56. 56 minus 2 is 54, so that angle right there is 54 degrees. Plug it in here, 6 times 14 is 84. 84 plus 4 is 88, so this angle, angle A, is 88 degrees. And once we know those two angles, then we can find this third angle here, because the three angles of a triangle have to add up to 180, so 88 plus 54, that's 2. 8 plus, that's supposed to be a 5, is 13, plus 1 is 4, 142, subtract that from 180. Borrow there, 7, that's 8, 38 degrees. So this angle ends up being 38 degrees. Now we can list the angles from smallest to largest. The smallest angle is this 38 degree angle here. Well, we have to name it with 3 letters. So angle ACD. So angle ACD is the smallest. I'm just going to use commas this time. The next smallest angle is a 54 degrees, so we can name it with 1 letter. That's angle D. And then the largest angle we figured out was the 88 degrees, so that's angle A. So those are the 3 angles from smallest to largest in that triangle. All right, number 9 is basically the same thing as number 7. So again, a little more difficult problem, but all you're going to do is pick 2 sides, add them together, and it should be larger than the third side. So I'm going to pick x plus 8, start off with, plus x. Those 2 sides should add up to be more than the third side, which is x plus 10. I really don't know which one's the longest, which one's the shortest. We're trying to just figure out what x could be. And this is going to give us some idea. This is 2x plus 8. Collecting like terms there, x plus 10. Subtract x on both sides. You end up with x plus 8 is greater than 10. Subtract 8 on both sides. And we now know that x has to be greater than 2. So we know x has to be bigger than 2. Maybe that's all we'll be able to figure out. We got to try the other sides to see. So next I'm going to do x plus 10 plus x, and say that's got to be greater than the x plus 8. So these 2 sides add together should add up to be more than that. Third side, like like terms, 2x plus 10 is greater than x plus 8. Oops, 8, not x. Subtract x on both sides, you end up with x plus 10 is greater than 8. Subtract 10, and you end up with x is greater than negative 2. That's a greater than symbol. Well, we already know x has to be bigger than 2, so x being greater than negative 2 doesn't really help us, because if x is bigger than 2, then x for sure is bigger than negative 2. Now we do the third pair of sides, or match up the sides the third way, and it'd be x plus 8 plus x plus 10 should be greater than the x. So this side plus this side has to be larger than that side. Collect like terms, you get 2x plus 18 is greater than x. Subtract x on both sides and you end up with x plus 18 is greater than 0. Subtract 18 on both sides and you end up with x is greater than, that's a greater than, negative 18. Well, again, same idea. If x is greater than 2, then we for sure know x has to be bigger than negative 18. So the best that we can know on this is x has to be bigger than 2. And if we start listing this in, and we know x has got, could be like 3, 4, 5, we could put those in here. So let's say we put in 3, just as an example. Well, this side's going to be 11, this side's going to be 3, this side's going to be 13. If we put in 4, this side's going to be 12, this side's going to be 4, and this side's going to be 14. And if we just keep going that way, you can tell which side's the biggest and which side's the smallest. We now know that this side has to be the biggest. It's always going to be the biggest. This side's always going to be the smallest. And this side's going to be the middle side. Well, if that's the case, and we want to list these angles in order, and they said list them in order from smallest to largest, well, the smallest angle is going to be across from the smallest side, so that's angle L. So angle L has to be the smallest. The next biggest angle is across from the middle side, that would be angle M. Angle M is the next one, and then the largest side is across from angle N. Ignore that extra mark there. So the biggest side's across from angle N, so angle N's got to be the biggest. So that's listing the angles in order from smallest to largest. Same thing on number 10, sort of a hard one. Probably the first thing I would do on number 10, instead of saying 3/2 x there, I'd probably change that to 1.5x, just to make it easier on us. We're going to pick two sides, and they should add up to be more than the third side. So I'm going to pick 2x plus 1 plus x, and that should be greater than the 1.5x. Might want to have your calculator handy. 2x and x give us 3x. 3x plus 1 is greater than 1.5x. I'm going to move the 1.5 over here, so subtract 1.5x on both sides. You end up with nothing on that side, or 0. And over here you got 1.5x plus 1. Subtract 1 on both sides. We end up with 1.5x has to be greater than, greater than negative 1. Divide by 1.5. And the first thing I notice with this is that this is going to come out where x is a negative number. So x has got to be greater than some negative number. When we look over here, x has to be bigger than 0, because this side cannot be 0 and it can't be a negative number because x is all it is. So you could actually just stop right there and say x has to be bigger than 0, and we already knew that just from this side just being x, so it has to have a length. So that really doesn't help us a whole lot. If you wanted to divide that, it ends up coming out x is greater than 1 over that is, what is that, 2/3, so negative 2/3. Well, knowing that x is greater than negative 2/3 doesn't really help us, because we knew that just from this right here that x had to be bigger than 0. The next one, if I pick two other sides, I pick 2x plus 1 and x the first time. So I'm going to pick x plus 1.5x, and that should be greater than 2x plus 1. This is, add those two together and you get 2.5x is greater than 2x plus 1. Subtract 2x on both sides. You end up with 0.5x is greater than 1. Divide both sides by 0.5. and you end up with x has to be greater than 2. Well, that helps us, so we know x has to be bigger than 2. Let's try the other sides. We got, let's see here, we got the 2x plus 1 plus the 1.5x, and that should be greater than just the x all by itself. That collect like terms, that's 3.5x plus 1 should be greater than x. Subtract x on both sides. You end up with 2.5x plus 1 is greater than 0 on that side. Subtract 1. You end up with 2.5x is greater than negative 1. Well, when we divide both sides by 2.5, you're going to end up with x is greater than, and again, we're going to end up with a negative number. So we know that that's not really going to help us, because we know x has to be greater than 0. It can't be a negative number because of this side right here. Sometimes x can be a negative, but this time it can't be because it's all alone on the side. But if you wanted to divide that, 1 divided by 2.5, I believe is negative 0.4. So the best thing that we got out of this is x has to be greater than 2. Well, if we know x is greater than 2, so again, we could stick in like 3. That means this side would be 3. If we stick in 2 right here, 2 times 2 is 4 plus 1 is 5. We stick in 3 right here, 1.5 times 3 ends up being, let's see, that's 4.5. And we could see that this is always going to be the biggest side, this is always going to be the smallest side, this is going to be the middle side. So this is the longest, shortest, and this one's the middle. And then we could figure out the angles. So we want smallest to largest angle. Well, the smallest angle's got to be across from the shortest side, so that means angle B has to be the smallest angle. The next smallest angle is across from the next shortest side, or the middle side, so that's angle U. And then the longest side has to be across, or the biggest angle has to be across from the longest side, so angle W has to be the biggest. There's our angles in order from smallest to largest. All right, on number 11, the first thing we're going to do on number 11 is find this third angle right here, and we find that by adding the other two angles and then subtracting from 180. That gives us 767. We subtract that from 180, and we get borrow there. That makes that 7. That's 113. So this angle right here is 113 degrees. We want to list the sides from what they say. List the sides from shortest to longest. So the shortest side is always going to be across from the smallest angle. So the 19 degree is the smallest angle. So the side across from that is QS. This time I'm going to use the alligator mouse. That's got to be less than the next shortest side, which is across from the 48 degree angle, which is RQ. It's supposed to be an R. And then the biggest angle, or I'm sorry, the biggest side is going to be across from the biggest angle, which is at 113. So that's segment RS. That's our three sides listed in order. QS is less than RQ, which is less than RS. Number 12, we jump to it. We know that these two angles are supplementary, so to get this angle, we just take 115 subtracted from 180, you get 65. To get this angle over here, we say that the three angles of a triangle should add up to 180, so 65 plus 52, that's 117. Subtract that from 180, 180 minus 117, borrow there. You got 3, 6, 63, so this angle down here is 63. We want to list the sides in order from smallest to largest, so we find the smallest angle, that's the 52, the side across from it is BC, so it's got to be the shortest. This time I'm just going to use commas and list them that way. That's the shortest side. Next shortest side is across from the 60 degree angle, or 63 degree angle. That's segment BD, or side BD. And then the 65 degree is the biggest angle, so the biggest side's got to be across from it. And that is segment CD. So that's our answer to number 12. All right, 13 and 14, these problems are a little more difficult because they're throwing in extra triangles. First thing you gotta do is always find anything that you can find fairly easily. Like I can find this angle right here pretty easily because 40 plus 80 is 120. Subtract that from 180, and that leaves me with 60. So that angle there has got to be 60. And add these two up, 75. 75 plus 70, that's 145. Subtract that from 180, and I get 35. So this angle down here, angle A, has got to be 35 degrees. Now what we're going to do is we're just going to look at the triangle on the left and do the same things that we've been doing. In that triangle on the left, this side has to be the shortest side because it's across from the smallest angle. The side across from the 75 degree angle here has to be the longest. The side across from the 70 degree angle over here has to be the middle one. So that's for the triangle on the left. Now we forget all about the triangle on the left and we look at the triangle on the right. The triangle on the right, the 40 degrees has to be across from the shortest side. So that side CD over there has got to be the shortest. 60, that's got to be the middle side. And then the side across from the 80, that's got to be the longest side. You probably can't read that, but that says the longest. Well, when we look at this, they share this side right here, BD, and then this triangle on the right, it's the shortest side, or I'm sorry, it's the longest side in the triangle on the right, and then the triangle on the left, it's the shortest. Well, that tells us that every segment in this triangle, if this one's the shortest over in this, the bigger triangle, the one on the left, every segment in that triangle's got to be bigger than every segment in the triangle on the right. So we're trying to list these sides in order from shortest to longest. We're trying to list all the segments, and we got 1, 2, 3, 4, 5 segments. So all I'm going to do, 1, 2, 3, 4, 1, 2, 3, 4, 5. I didn't need that last one. And we're going to list them there. Well, we want to go shortest to longest. Well, if every side over here in this triangle on the right is shorter than the sides in the triangle on the left, except for the middle one, which is the same in both of them, then we know that this one has to be the shortest segment of all of them. So segment CD has to be the shortest. Then this middle one has to be the next shortest. So segment BC has to be the next shortest. And then these two are actually the same. They're the same length. And that's because they share that. So it's segment BD and segment BD. And we really don't need to put segment BD in there twice. That's why we only had 5, and now I am going to use that one since I put it in there twice. But we really didn't need that a second time because we only are going to list 5 of them. And then we go over to this one. Well, if that's the shortest one, then the middle one, the next shortest, is AB, segment AB. And then the longest segment out of all these segments in this picture is this one down here, which was the longest in the triangle on the left, which is segment AD. No real easy way to do this. You just got to sort of think it through and use a little common sense that, hey, if that segment BD is the longest side in one triangle and the shortest side in the other triangle, then it's everything in this triangle on this side's got to be bigger than everything in that triangle on that side, except for the one side they share. This one, same idea. I'm going to find the angles first. 80 plus 60 is 140. Subtract that from 180. That leaves us with 40 degrees there. Here, 40 plus 75 is 115. Subtract that from 180 and you get 65. So that angle's 65 degrees right there. These two, 110 plus 40 is 150. That leaves 30 degrees for that one. And we're basically going to do the same thing, except this time we got 3 triangles that we got to think through. In the big triangle over here on the right, that's got to be the longest side. across from the 40-degree angle, that's gotta be the shortest in that one. And then that means this one up here is the middle side. In this triangle, got the 75-degree angle here, so that side over there, that has to be the longest. Well, notice again, it was the shortest in this big triangle over here, but it's the longest in this smaller triangle. This side's going to be the middle, and then the 40, this one down here is going to be the shortest. Now then we look at this small triangle down here, and this angle right here is 110, side across from it's going to be the longest. And notice how it was the shortest in this this triangle, but it's the longest in this triangle. Side across from the 40 is going to be the middle, and then the side across from the 30 over here has got to be the shortest. So what we're saying there is every segment in this triangle is longer than every segment in this triangle except for the one that they share, and every segment in this triangle is longer than every segment in this real small triangle on the bottom except for the one they share. So all we're going to do is go from long on this triangle all the way down to this small one, and that'll put them in order. Or actually they want them from shortest to longest, so we're going to start down here and we're going to go from the very shortest one all the way up to this one here, which is the very longest one in this picture. So the shortest one in this small triangle is segment ED. That comes first. Then the next shortest one is segment AE. Then the next shortest one is segment AD. And segment AD is also in this second triangle. I'm not going to list it twice this time. Then the next shortest one would be AB right here. Then the longest one in this triangle is segment BD. Then we're jumping to this triangle, and I'm not going to list BD again. Again, it's in both triangles. I'm running out of space over there, so I'm going to have to rewrite the rest of the list down here. Then we want the next longest one in this one, which is segment BC. And then the very longest segment in this and all of this picture is segment DC. So that's all of our segments in this picture listed from shortest to longest. We don't know what any of them are as far as their links go, but we do know that ED is the very shortest in the picture and DC is the very longest, and all the rest of them go in order that way. All right, on the back side, problem 15, again, this theorem says if these two sides are congruent, these two sides are congruent, we can look at the angles in between them, and we can compare the sides across from those angles. Can't say exactly how long those sides are, but we can compare them. So we're looking at this, and we see that this is a smaller angle than the 115, so that means that segment DF has to be shorter than segment AC in this. So AC's got to be the smaller one. AC's got to be the smaller one, so I look up here at my blank. So AC has to be, and we got to pick either less than, greater than, or equal to put in that blank. And this time we're going to pick less than. Don't think that that means less than or equal to. AC is less than segment DF. Since I'm sorry, that's wrong. It's greater than. I looked at it backwards. AC is greater than DF. Since this side is across from the bigger angle, then it's got to be longer. Sorry about that. Next one, we're looking at angle HGI. HGI, that's this angle, and we're trying to compare it to angle IGJ, this angle. Well, on this one, we know that this side's the same as that side. Also, we notice that these two triangles share that side, the reflexive property, so that side's congruent to itself. And we look down here, the side across from that angle that we're trying to compare is 6, the side across from this angle that we're trying to compare is 6. Well, we notice that those two are the same. Well, if they're the same, then that means those two angles have to be equal to each other. Number 17. I know this side's congruent to this side, I know this side is congruent to that side, and I'm trying to compare angle 1 and angle 2 there. When I look at angle 1, it's across from a side that's 11 units long. Angle 2 is across from a side that's 14 units long. And remember, these always have to be the included sides, or the included angles, so they have to be between the two sides that you're dealing with. Angle 1's across from the 11, angle 2's across from 14, angle 2's across from a bigger segment, so angle 2 has to be bigger. So that means that the Pac-Man, let's get rid of that again. The Pac-Man, the alligator mouth, whatever you want to call it, is going to open towards the bigger one. So the measure of angle 1 has to be less than the measure of angle 2. We look at this one again, we notice that these two triangles share that segment right there. So by the reflexive property, that segment has to be congruent to itself. Well, we got this and the two triangles, and then this side's congruent to itself and the two triangles. We're trying to compare this segment with this segment. We look at that segment, it's across from the 35-degree angle. That segment's across from a 19-degree angle. Well, the 35 is bigger, so that means this segment MN has to be bigger. And again, let's get rid of that. So the MN has to be the bigger one, so the open end is going to go towards that, and it says KL is less than segment MN. So KL has to be shorter than segment MN. Number 19, they want us to write and solve an inequality for the possible values of X. So we're looking at this, and we notice that this side's congruent to that side, and we also notice that these two triangles share that side, so it's congruent to itself by the reflexive property. We look over here, this angle and this angle with the X's in it are across from 3 and across from 2. Well, this one, the 2x plus or minus 3, has to be bigger than this one, the x plus 7, because it's across from the bigger side 3. So 2x minus 3 has to be greater than x plus 7. Subtract the x on both sides, you end up with x minus 3 is greater than 7, add 3 to both sides, and we end up with x is greater than 10. And that's the most that we can do. That's telling us the possible values of x. We know that x has to be larger than 10. Can't be 9 or 8 or 7 or anything smaller than 10. It's got to be bigger than 10. 11, 12, 13, maybe 10.5, whatever. But it has to be that, otherwise this won't work. All right, on this one, we know these two sides are congruent. The two triangles, these two sides are congruent. We look at our angles. This angle's bigger than this angle, so the side across from that should be bigger than the side across from this one. So this over here should be the biggest, so 6 times x plus 1 should be greater than the 14x minus 10. You distribute out here, you get 6x plus 6 is greater than 14x minus 10. Subtract 6x on both sides. You end up with 6 is greater than 8x minus 10. Add 10 to both sides. You end up with 16 is greater than 8x. Divide by 8. You end up with 2 is greater than x. If you want to turn that around, you just got to remember that the point is going towards the x, so if you turn it around so it makes more sense to you, x with the point going towards the x has to be greater than 2. So we know in this case x has to be larger than 2. On 21, they want to know which segment's bigger, BC or DE. We look at this, we see we got two sides congruent here, two sides congruent here. So we compare the angles that are between them. This is 110. So the side across from that, which is BC, should be bigger than the side across from this angle, which is only 95. So we know that BC is the larger of those two segments. So BC has to be greater than, so the open end of the alligator mouth would go towards BC. Next one, a little tougher on this one. We know, I think I forgot to mark something here. Yep. We know that this side's congruent to that side. We also know that they share segment JH there, so JH is congruent to itself. Well, we don't know this angle right here, and we don't know this angle, but we can find it. 70 plus 75, and we always gotta find that included angle. 70 plus 75 is 145. Subtract that from 180, you get that this angle is 35 degrees. Same thing down here. 80 plus 55 is 135. Subtract that from 180 and you get 45 degrees. Now we can compare the side across from that 35-degree angle to the side across from that 45-degree angle. The side across from the 35-degree angle, which is GH, which in my picture it doesn't look like it, but it's the way it is. It's going to be smaller than the side across from the 45-degree angle. So this is smaller and this one's the longer. So JI is actually bigger, so the greater than symbol goes in there. All right, 23, we're trying to compare angle 1 to angle 2. We know that this side's congruent to that side. We also know that they share KN, so that side's congruent to itself. Well, we can look at the sides across from angle 1 and angle 2 and compare them, and that's going to tell us how angle 1 and angle 2 compare to each other. The side across from angle 2 is 3x, the side across from angle 1 is 5x. Since 5x and 3x, neither one, you can't have x as a negative, because then that'd make this whole side negative. So we know x has to be larger than 0. Well, anything you put in both these that's bigger than 0, like if you put in 3, it's going to give you 15 here and 6 there. This side over here is always going to be the biggest, so that tells us angle 1's got to be bigger than angle 2, so the greater than symbol goes in there. 24, we're going to compare angle U, this angle, to angle R, which is this angle. To compare those two, we just first thing we got to realize is that we know this side's 5, so that side's congruent to that side, which is 5. This side's 4, so it's congruent to this side, which is 4. Angle U is between those two, so we look at the side across from angle U, which is 3, and we look at the side that's across from angle R, which is 3.1. Well, this one's bigger, so that means angle R's got to be the bigger of those two angles. So that means the less than symbol is going to go in there because the open end's got to go towards angle R.